There we go. All right. So we are working on our 4.5 dilations notes today. Our objective is that I will be able to identify and perform dilations. Okay, so we want to first understand what a dilation is. Okay, and once we understand what a dilation is, then we're going to be able to perform dilations ourselves. So far, we have done translations, which have been slides of our figures, moving one thing from one place to another with a slide. We have done reflections, which have been essentially mirror reflections, either across the x-axis, across the y-axis, across another line. And then we did reflections with our Edpuzzle video where, I'm sorry, not reflections, rotations. So we did rotations with our Edpuzzle video. And you know, a rotation is literally you take something and you rotate it around the center here, right? And it changes its direction a little bit, but it's still the same figure. All three of those are called rigid motions, right? They keep the figure exactly as it is. They keep the shape, they keep the size. All they do is change the position or the orientation. Dilations are the only transformations that change the size of a figure. They change its size, okay? So a dilation is a change in size. So it is a transformation in which a figure is enlarged, so it's made bigger, or reduced with respect to a fixed point called the center of dilation, and something called a scale factor. Okay, now the scale factor is very important because the scale factor is the ratio of the lengths of the corresponding sides of the image, okay, and the pre-image. The letter K is used to name the scale factor. So the scale factor is denoted with the letter K here. So whenever we have K there, that's what we're talking about. Okay. So in order to find our scale factor, right, we said it's a ratio. Okay, what does the word ratio mean? What does the word ratio mean? Anyone know? Anyone want to take a guess? Ratio. Come on, you guys have heard the word ratio before.
Yeah, I've heard of it.
What do you think it means?
It's like fractions. Like, isn't it like a fraction? Wait, no.
Yeah,
I heard on the
exactly.
video on the game. It's like one overweighs each other, and then it comes up with a number. It's either negative or positive or equal.
Okay, yes, absolutely. Okay, so ratio is pretty much like a fraction, or it's a comparison of numbers that then can simplify, right? So with the scale factor, okay, our ratio is found in a specific way. Okay, we want to find the ratio of the image and the pre-image. So what we do is we take the pre-image information, not pre-image, I'm sorry. Don't write that down. Hold on, where's my word now? I made a boo-boo. It happens. Okay, so it's image over pre-image. It's image over pre-image. Okay. So to find our scale factor, we have image over pre-image. Okay. And what I mean by that is like, if we have like segments, right? And we want to see one is larger and the other one has been dilated. Whatever the length of the image is, we'll put over the length of the pre-image, and we will get our scale factor. So for example, okay, we have triangle DEF, okay? Triangle DEF is the image of triangle ABC after a dilation. We want to find the scale factor, okay? We want to find the scale factor, okay? So triangle DEF is the image of triangle ABC. So which one is the pre-image and which one is the image? Which triangle is the image and which triangle is the pre-image? Okay, it says triangle DEF is the image, right? So DEF here, DEF is our image, which makes triangle ABC the pre-image. Okay, so what does that mean? That means we started with triangle ABC and we enlarged, okay, we dilated by enlarging to triangle DEF. The question at hand is, how much did we enlarge by? What's the scale factor that we enlarged by? Because if we're starting with triangle ABC, that's our pre-image. And if our image is triangle DEF, that means we started here and ended here, okay? So in order to find our scale factor, we want to identify the corresponding sides of these triangles, okay? We want to identify the corresponding sides of these triangles. So we can see here, based on the angles, this angle is congruent to this angle. We can see from the arc marks there, remember, the same number of arc marks represents congruent angles, right? So we have this angle here and this angle, they're congruent. Angle B here and angle E each have 2 arcs, so they're congruent. And then angle C here and angle F have 3 arcs, so they're congruent. Okay, so how does that help us? Well, the sides between the same 2 congruent angles are corresponding sides. So that means that AB is corresponding to DE because angle A is congruent to angle D and angle B is congruent to angle E. Okay. And then we have side BC here. Angle B is congruent to angle E and angle C is congruent to angle F. So that means BC is corresponding to EF. Okay. And then lastly, angle A is congruent to angle D. Angle C is congruent to angle F. Therefore, AC, side AC, is corresponding to side DF. Okay, corresponding, remember, means in the same position, right? In the same position. So we're not saying that the sides are congruent. They can't be. This is 10, this is 20, this is 6, this is 12, that's 7, that's 14, right? But they're corresponding, meaning they're in the same position. Okay. So how does identifying the corresponding sides help me out? Well, if I'm trying to find the scale factor, which I am, okay, I can make a ratio of the corresponding sides and figure out my scale factor. So I can take a pair of corresponding sides. So let's say I have AB and DE. They're corresponding, okay? The way my ratio works is image over pre-image. So my image was DE, that's from my image triangle. My pre-image is AB. That's for my pre-image triangle. So I can do DE over AB. These are the two corresponding sides from my image and my pre-image. And then I plug in their lengths. DE is 20 over AB, which is 10. Okay, what's 20 over 10?
2.
2. Okay, so with these sides, based on these sides, my scale factor is 2. That means triangle DEF was dilated with a scale factor of 2, meaning it was enlarged by a scale factor of 2. It could also be said that triangle DEF is double the size of triangle ABC, okay? Now, I could have used any of these other pairs of corresponding sides. So I could have also found K by using BC and EF. As long as I'm making sure the image is on top and the pre-image is on the bottom. So in this case, my image is EF and my pre-image is BC. And I can plug those guys in. EF is 12 by length. BC is 6. This should simplify to the same scale factor, right? Right, 12 divided by 6 is also 2. Okay, even with the third side, this should work. So if I do my image DF over the pre-image AC, okay, that's 14 over 7. And that's also going to simplify to 2. So my scale factor is 2. Okay, and since triangle DEF is the image, I can say that triangle DEF is double triangle ABC, because a scale factor of 2 means that it's 2 times as big. Okay. So it's very important that you identify your image and your pre-image. So this was our image, and this guy here was our pre-image. Because we started with triangle ABC and we ended with triangle DEF. And it was told to us right there. That's how I knew. Triangle DEF is the image. Okay. So let me give you guys a minute to finish writing that down. Okay. Okay. So there are some rules about K, about our scale factor. Okay. So if our scale factor K is a number that is greater than 1, like in this situation here, right? We had a 2, or it could be 1.5. Any number that's greater than 1. Then that dilation is considered an enlargement, okay? So the dilation is enlargement, is an enlargement. So if our scale factor is greater than 1, any number greater than 1, then the dilation is an enlargement. However, if our scale factor is any number between 0 and 1, any number between 0 and 1, okay? That means a decimal like 0.5 or 0.3 or 0.8, okay? Then the dilation is called a reduction. It is called a reduction. So if your scale factor is greater than 1, it is an enlargement. If your scale factor K is less than 1 but greater than 0, then it is called a reduction. Okay? Now, if you remember earlier, I said that dilations, right, are transformations where a figure is enlarged or reduced with respect to a fixed point called the center of dilation, okay? So the center of dilation is essentially like the point that is the center of where an image is being dilated from, okay? So in these next examples, C is going to be our center of dilation. This point right here is going to be our center of dilation. So to find our scale factor, okay, we want to find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement, okay? So remember, if it's greater than 1, it's an enlargement. If it's less than 1 but greater than 0, it's a reduction, okay? So to find the scale factor, we're going to be using the distance of a point from the center of dilation. So we're looking at point P here. P and P prime, okay? So when we take a look at this, our point P, okay, whenever you have a regular point like that, and then you have that same point with a prime, this tells us that the P is our pre-image, and then the prime is our image. So it is whatever we did the transformation on, okay? Mr. L, the other way there. P is the pre-image, P prime is the image.
I am so sorry. I wish I could erase that.
It's all right. Okay. So when we want to try to find the scale factor here, what we're going to do is we're going to use the ratio. Remember I said image over pre-image, right? So our image is going to be the distance from C to P prime. And our pre-image is going to be the distance from C to P. Okay. So to find our scale factor, we're going to look at the distance from C to P prime, and we're going to put that over the distance between of C to P. So if we take a look here, we have some nice distances for us. Okay, we can see that C to P prime here is given to us as 12. So this is going to be 12 over the distance between C and P is given to us as 8. So that's going to be 12 over 8. Okay, and we can simplify that. We can simplify that and leave that as a fraction, or we can simplify that as a decimal, whatever it ends up being, right? So 12 divided by 8 here. Don't mind the giant calculator. You'll eventually get to use one of these graphing calculators. But 12 divided by 8 here is 1.5. So that means our scale factor is equal to 1.5. Okay. Now I know this is a decimal. So a lot of kids might think 1.5, that's a decimal, it must be a reduction. Nope, right? 1.5 is greater than 1. Therefore, this is an enlargement. This is an enlargement. Okay. So let's do one more example, yes? And I zoom out so you guys can keep seeing A there. Okay. I'm gonna zoom out so we can keep seeing A there, and we're gonna look at B, okay? Again, we're using the points. Wherever we have a little apostrophe, that's our prime. That's gonna always be our image, okay? So in this situation, P prime, our image is here. And this P here without the prime, this is our pre-image. Because this P doesn't have a little apostrophe, right? Indicating that it's prime. Prime usually indicates that we've transformed it. Okay? But the ratio for our scale factor doesn't change. It is still image over pre-image. Okay, so here is our center of dilation. And once again, to get our scale factor, we are still going to do the center to our image point, so C to P prime, over C to our pre-image point of P, so CP. Okay, so we're looking at the distance from C to P prime right there. And we can see that that distance here is given to us as 18. So this top is 18 over our distance here from C to our pre-image P. We have 30. So this is going to be 18 over 30. Okay, so when I put this into the calculator to get a decimal, okay, it's going to be 18 divided by 30. I don't change up, I don't switch it up just because 30 is bigger. Okay, so it's 18 divided by 30, which gives me a 0.6. So I have a 0.6 as my scale factor here. Okay, so my scale factor K is equal to 0.6. Now this is a decimal, and the initial number, right, there wasn't a 1 in front of it, it's 0. So it is a number between 0 and 1. It's less than 1, but it's bigger than 0 because it's not negative. Okay, so this will be a reduction. Okay, this will be a reduction. Okay, in the participants window, can I please get a thumbs up or a thumbs down on our understanding of examples A and B? Okay, a thumbs up means I understood them. Thumbs down means I'm iffy on them or I don't understand them, or I have questions on them. I want a response from everyone. Thank you, Andres. Thank you, Destiny. Thank you, Gabe. Thank you, Heaven and Jasmine, for your responses. Thank you, Mariel, Michael, and Maya for your response. Thank you, Zavon, for your response.
And Jose?
And Jose, yes, I did not see him.
Marielle, Michael, Maya,
Thank you, thank you.
Kaylee.
Thank you, Callie. Let's see. Still
Where are the
waiting
rest?
on, yeah, I know. Still waiting on responses from Bethany, from Caleb, from Denise, Harmony, Jayla, Joshua, Kebra, Leanne, Ureli, and Ulysses. I still am waiting on responses from you guys. Thank you, Caleb. Still waiting. I'll give you guys 30 more seconds to respond before I start taking notes for participation.
You're writing down participation points, right?
Oh, yes.
Where is Joshua, Kebra, Leanne, Ureli, Samson?
Guys, there's nothing
Harmony.
wrong with giving me a thumbs down. I just need a response. That's all I need. Up or down. Give me a thumbs up or a thumbs down response saying
That
you
worked.
understood it, or you have some difficulty with it, or you need an explanation, or you need some clarification. Nothing wrong.
We're only missing one. Fantastic.
Oh, well, look at that. Harmony, are you there? And Bethany. Harmony and Bethany. Okay. Well, looky there. Thank you so much. I love that all of you guys have your thumbs up. That's awesome. It's kind of weird because I find it difficult to know, or I find it hard to believe that no one needs a clarification unless I'm such an amazing teacher. No, I'm kidding. That's probably one of you probably has a question. If you have a question and you're too shy to say it out loud, please type it in the chat, at least like privately, and I can answer your question for you. But I don't know that you have a question until you tell me what the question is, guys. So please, 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 if you have a question, ask, okay? All right, so next we have some U-tries. Okay, so find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. Okay, so you're doing the same exact thing we were doing up here. It's pretty much the same thing. Pay attention to the P and the P prime, okay, to identify your image and your pre-image. I'm going to give you guys a total of 5 minutes here to do A and B, okay? A total of 5 minutes, and then we gotta move on to keep pace. Okay, so 5 minutes.
Bye.
Bye, have a good one.